Hey, everybody. My name is Benjamin Cox. I'm going to be walking through a brief session on kind of AI ethics and how it pertains to risk management. Some background on me. I'm a director at H2O.ai, a AutoML machine learning cloud services company. And I've spent about 5, 6, 7 years doing analytical consulting for big financial services firms where risk management is a high priority and a legal requirement. So we've got a lot to cover and kind of get through, but we're going to try to hit all the main areas here, discussing, how machine learning interacts with risk management and what that means across different kinds of companies. So the way that we're going to look at this is kind of an overview of background of why we're having the discussion in the first place, what is risk management, and then kind of methods and tools you can apply to, have best practices at your company, whatever industry you work in around risk management as you start to bring on, machine learning and data science tooling. So some background is that, just from the top of the house, as you start bringing in automatic decision engines, i.e. data science, machine learning, AI, it's more important than ever to think about what the risk profile is of the decisions that these models are making, right? So traditional risk management can vary, obviously it would be very different in financial services versus agriculture, what that means to them. But, in non-probabilistic systems, risk management is sort of, a more linear exercise. But when you start to bring in kind of models that learn and evolve over time, you need to build more robust review structures, monitoring structures, frameworks to, be able to handle that risk that's brought in by, algorithmic decision engines. Right. And then, start to think about what to do if models break or if something goes wrong and you need to shut the system down. So what is risk management? It's really the practice of kind of building frameworks or tools or processes in place to prevent tail risk events of, whether it's a decision that's being made, kind of a forecast that's being made. Really, the goal is, depending on what your business is and what kind of risks you bring on, is to build a practice around preventing the worst possible scenario based on whatever happens in your business, right? So the kind that I want to talk about specifically with machine learning and data science and AI is really kind of, brand risk, complexity risk, discrimination and bias risk, automation risk, and maturity risk or materiality risk. So I want to kind of unpack what those mean in relevance to machine learning, right? So machine learning systems are inherently very complex and they aren't the most transparent. So, whenever you have a machine making systems and it's not entirely clear why it's making the decisions that it is, you need to understand the complexity that you're bringing in, and you need to understand, what kind of human demands that'll bring in as well. Automation in general, when you're kind of moving workloads to machines and not to people, there's less oversight that can happen there. So you need to understand, as you move towards automation, what risks are being pushed onto a machine and not a person, and how you kind of reconcile that out. And then bias and discrimination is really, more of a data question often than a machine learning question, but data sets carry bias all the time. And statistical bias is a thing that, you actually look for. So it's important to understand, are your models perpetuating, human or operating biases that exist in the data set? And then should it be, what can you do to sort of strip that out? And then brand risk. Like, I think everyone will have seen, kind of toxic headlines about an AI system going rogue and, some Twitter bot becomes racist or sexist, and it's very bad for the optics of the company. And how do you start to quantify what that brand risk might look like? Should you end up in the headlines? What does that do to, customer loyalty or brand loyalty? So best practices qualitatively, we did a bunch of writing on this last year about sort of the people, process, and technology considerations, a very consultative approach. And so from a people perspective, you can implement, teams like governance, risk, and compliance teams or model risk management teams. You'll see these in financial services firms all the time. And that's just building a human framework of review, oversight, audit, monitoring. So if you have models that are in production, you know what's going on with them, how they were built, you have it thoroughly documented. And then process, right? So once you have those teams in place, what you really want to do is create a reproducible workflow for data science experiments, right? In science, it's all about reproducibility of an experiment to prove out a hypothesis. And that should be the same for your machine learning exercises, right? You should be able to go back, at every step of the process and recreate that decision or that experiment or that analysis. And then technology, it's really about choosing tools that enable you to, before you've even built a model, understand your data better, build more transparent models, and then after the fact, using kind of leading methodologies and tools, which we'll look at, to sort of unpack those models as well. So quantitatively, there's a lot of new tools coming out to help unpack and analyze models. And that requires, hours of its own discussion and evolves rapidly. But I think the four that I tend to look at the most and use the most in the field, one will be disparate impact analysis, which, as it sort of implies, is a tool that kind of analytically will say this class or this group or this population is being treated adversely relative to its peers, right? And so that's where you start to find like, are men being treated more fairly than women in a certain data set or something to that degree, and that you really do want to know that, and there are some legal implications there as well. Shapley values is just a much better form of feature importance, so you can really learn at the aggregate and at the macro level how important certain features are and how important they are in a positive and a negative connotation. Partial dependency plots will show you for each column, essentially every category underneath that column and what that impact will be to the net model. So, you'll see some ages might be really predictive, some ages might not be predictive, some might be negatively correlated. And you kind of want to understand at a sub-feature level what the model thinks about those categories or those feature categories. And then decision trees and rule-based systems, when you build random forests or GBMs, oftentimes you can actually visualize it in tree format. And it's really useful to see, how a model traverses a decision tree, at each interval with each feature to understand how you get the most, the highest populated groups or the most rare groups. And just being able to visually show how a model is making a series of decisions is really, really useful and really, really helps get, non-technical people on board as well to understand that. So, these are all kind of like high level ways to do this. What I do want to say for any type of machine learning exercise, there's three things that I kind of think about pretty quickly. One is velocity and volume, right? Like, so how many decisions are being made by this model per hour, per minute, per day? What is the magnitude or materiality of those predictions? Like what value do you expect to make on each prediction, or what could you lose on each prediction based on what the decision is and if it's correct or if it's not correct? And then, you can get an understanding of what, is the notional risk going on within that system because you understand the frequency and the magnitude. So it's kind of, a physics equation in that regard. And then kind of continuity and backstops, right? Like, so if you have to shut a model down, what's your business continuity plan? Do humans step in? Do you replace it with another model? You need to understand how much money you're losing if that has to go offline and what your recourse is from that. So in closing, there's a lot of ways you can kind of do this. And these are the ones that, I sort of talk about with companies the most, right? You really want to build a culture of challenging these experiments, right? Not just accepting output and saying, okay, we're good to go, but really doing kind of scientific rigor and seeing if you can break that or if you can find scenarios that will break a model. Bringing model risk into the business, it's a key part in financial services, and it's a really good kind of starting place for companies who want to take this stuff seriously to kind of, replicate. Always be continually testing and challenging models, right? Most model ops tools will enable you to kind of periodically challenge and test, and you want to be doing that always. You always want to be seeing if you can make a model more simple or if you can make it more accurate, right? So, very aggressive analyzing of the data pipeline. You really want to understand and get under the hood of how that data was created, collected, sampled, and split for the experiment. And then, always look for the simpler solution, right? I think every experiment should start with, a basic linear model and kind of get more complex from there if you believe that you can add alpha in that regard. But simple tends to be better. Simple tends to be more resilient, more robust, stronger. And then the last comment is really kind of building these practices up front really reduces on long-term technical debt and long-term risk, non-market risk of oversight, regulation, and policy. So, the more you can get out in front of this, the more you don't have to face those kind of cataclysmic, okay, we've got to shut everything down and reassess from the ground up. You really want to build a strong, data science ecosystem that's like built to last, right? So all that being said, there's a lot that can go into this, and there's a lot of different areas people spend a ton of time researching, but this should serve as kind of a crash course in understanding the risks that you bring in with machine learning and some of the best ways you can kind of counteract it early and often.